Pterygotus takes a back seat. The largest Hybopterus specimens could reach 6 to 6.6 feet. They were likely record holders as the heaviest of their kind, due to their broad and compact bodies. This giant's feeding method wasn't that different from that of its smaller relatives. It still used the same sweep feeding method, except their diet may have included larger reptiles and amphibians. And no, this still isn't the limit for giant arthropods. The largest representative of this kind can confidently be considered Echolopterus, which lived 400 million years ago. It reached a size of about 7.5 to 8.5 feet, making it one of the largest arthropods ever discovered. This giant's primary tools for defense and hunting were its claws. They could be approximately 1.4 feet long and were powerful enough to grab and easily crush its prey. However, such a large size did not equate to massive weight. Due to the simplicity of its anatomy, despite its length being comparable to a car, the weight of a Echolopterus likely did not exceed 220 pounds. Not all creatures of the Carboniferous period were affected by the giant gene. Amid the humid prehistoric jungle, where enormous dragonflies filled the skies and the waters harbored giant scorpions, there were other beings, creatures so tiny you would struggle to spot them underfoot. Known as trigonotarbids, these can be considered prototypes of the first spiders in history. The smallest members of the species were just a few millimeters long, while the largest grew to 2 inches. These were the earliest terrestrial arachnids known to science, having appeared over 400 million years ago, long before the Carboniferous period. They were fully adapted to breathing air and no longer dependent on water. Their appearance was not too dissimilar to modern spiders. Their bodies were divided into a cephalothorax and an abdomen, segmented and covered in chitinous plates. Their legs were also similar to those of modern spiders. However, unlike modern spiders, they could not spin webs. Their cephalothorax was protected by a carapace, earning them the nickname armored. These were some of the smallest predators of their time, hunting soft-bodied invertebrates like worms. For example, they likely didn't use venom for hunting, and instead relied on grabbing their prey with their legs, holding it in place to consume it. It's possible that they also fed on plants, not unlike certain mites. For reference, they had a similar appearance to trigonotarbids. The Carboniferous period was a playground for evolutionary experiments, with unique, gigantic, and often dangerous creatures dominating the air and land. Yet, perhaps one of evolution's most fascinating experiments during this time was conducted underwater, creating some of the most well-armored creatures of the era. Lepidopterus was an ancient worm species that lived around 400 million years ago in what is now modern Australia. They thrived on shallow reefs and fed on organic waste. Measuring only a fraction of an inch in length, these creatures could only be observed in detail under a microscope. However, they had another, more memorable nickname, the Excalibur worm. This name, inspired by the legendary sword of King Arthur, was earned for good reason. Externally, they resembled heavily armored knights, covered in overlapping plates of calcite crystals that extended along their entire body. This armor provided extremely durable protection. Beneath the crystal layer was a light exoskeleton, similar to how knights wore chainmail beneath their armor. Additionally, the Excalibur worm could curl up into a ball, protecting its unarmored and therefore vulnerable body parts. The sharp edges of its crystalline armor made it even more formidable to potential enemies, as they would protrude outward when the worm curled up. Few creatures were capable of harming these armored worms. Biting through their crystalline shell was nearly impossible, and swallowing them was not a great option either. Evolution provided these worms with flawless defenses, but in the end, this came at a significant cost. Even this solid protection, which guaranteed safety from predators, had a downside. The heavy armor limited their mobility, making it difficult to search for food or disperse to new habitats. As a result, the Excalibur worm left no noteworthy descendants, and their ultimate extinction coincided with the mass extinction at the end of the Devonian period. Amphibians began to diversify, and reptiles evolved into forms much like modern-day lizards, with a backbone allowing them to live and move on land. These amphibians were also huge, and some species were predatory, resembling modern-day crocodiles, armed with sharp teeth and reaching lengths of almost 6 meters long. Like modern-day crocodiles and alligators, some evolved to have thicker, scaly skin, which solved the problem of their bodies drying out if they were out of the water for too long. For the first time, amphibians evolved to lay amniotic, or air-breathing, eggs on land, and that changed everything. Since these animals could now live out of and away from water sources, the Carboniferous period gave way to the Permian period, which began approximately 300 million years ago, just 50 million years before the dinosaurs. All the continents during this period existed as one large landmass called Pangaea. The first large plant-eating and meat-eating animals evolved during this time. Some of these creatures could be mistaken for dinosaurs, but they were actually more closely related to mammals and reptiles. One of these bizarre creatures was Phenodon. It looked a little like a salamander, averaging around 1 meter long, but its head was shaped like a boomerang. Another new reptile on the planet was the iconic Dimetrodon, which grew to about 5 meters long and had a large sail on its back, which was likely used to regulate its body temperature. During the Permian period, mammals were increasing in dominance. The biggest of these were creatures classified as Gorgonopsians, which were a class of giant bear-like animals with specialized teeth for different functions. These animals could be either herbivores or carnivores and varied in size from less than a kilogram to more than a ton. One group of these creatures was known as cynodonts. Their name means dog-like teeth. These animals exhibited social behavior, and fossil evidence shows that they hunted in packs. In the oceans, fish with true bony skeletons evolved, and sharks and rays flourished, along with sponges and coral. On land, insects evolved with adapted mouthparts that allowed them to pierce and suck. However, around 252 million years ago, the Permian era came to an abrupt end due to a cataclysmic event that caused a mass extinction. In 2001, scientists made a chilling discovery. A massive comet or asteroid, similar to the one that put an end to the dinosaurs, wiped out the giant reptile predecessors 200 million years earlier. But how did scientists come to this conclusion? Molecules of helium and argon gas were found locked in carbon in high proportions, which could have only come from space. It's estimated that the asteroid or comet was between 6 and 12 kilometers wide in diameter. Researchers say the strike would have released energy 1 million times greater than the biggest earthquake of the last century. Aside from this discovery, there's evidence that present-day Siberia and China experienced volcanic eruptions on an unimaginably massive scale. Those eruptions created dust and ash clouds that blocked out sunlight. Not only that, but over 1 million years, 3 million cubic kilometers of lava poured out of the ground, covering the entire planet in a layer 10 meters thick. The asteroid impact, combined with volcanic activity, was the proverbial blast from a double-barreled shotgun. The Earth was once again a very unhappy place. The combination of these two events resulted in what's called the Great Dying. 90% of all marine animals and 70% of all land animals that were alive during this time perished. The extinction event of the Permian-Triassic era, 252 million years ago, marked the beginning of the Mesozoic era, which includes the Triassic, Jurassic, and Cretaceous periods, lasting 186 million years. During the Triassic era, there was one vast supercontinent called Pangaea, which was mostly vast deserts with a hot and dry climate, surrounded by a huge ocean called Panthalassa. Dinosaurs would begin to evolve during the mid to late Triassic period. When we talk about dinosaurs, we immediately imagine towering and thundering animals like Tyrannosaurus rex. But new research shows that dinosaurs and their pterosaur relatives evolved from extremely small ancestors. Proof of this theory was discovered in Madagascar when a newly discovered reptile species was found, named Conodont kelly, or tiny bug. It lived around 237 million years ago and stood just 10 centimeters tall. It is one of the first small animals found at the root of the dinosaur family tree and represents an important discovery. The miniaturization event in which it lived served as a survival strategy for early dinosaurs, and the wear on its teeth showed that this tiny creature preyed on insects, which helped eliminate competition with its relatives for meat. Additionally, studies of this tiny dinosaur relative revealed that feathers and other fuzzy skin coverings, found later on true dinosaurs and pterosaurs, likely originated to protect these tiny dinosaur ancestors from the extreme climate of the mid to late Triassic period. When the first dinosaurs evolved, the Triassic period marked the rise of reptiles, mainly the archosaurs, or ruling lizards, and therapsids, or mammal-like reptiles. For reasons unknown, the archosaurs had an evolutionary edge, outcompeting their mammal-like cousins and evolving by the mid to late Triassic into the first true dinosaurs, such as Eoraptor and Herosaurus. Dinosaurs were divided into two main branches: Saurischia, lizard-hipped, and Ornithischia, bird-hipped, dinosaurs. Eoraptor was at the root of the Saurischian family tree. It was only 91 centimeters long and weighed about 11 kilograms. It had long legs that allowed it to run fast, and its front paws had sharp claws that helped it grab prey. Herosaurus was more advanced in evolution than Eoraptor because it had a joint in its lower jaw. It had a large skull, and its jaws were armed with sharp teeth, typical of a carnivore. It averaged a length of 3 to 6 meters and had 5 fingers on each predator that weighed around 30
with
kilograms.
blunt claws.
And although it was somewhat small,
was another early
it
true
probably
dinosaur,
had no trouble dealing
about
with
2
larger
meters
prey.
long,
With a large
Herosaurus
skull that
and
was as long as its
Storosaurus
femur
are prime
It had
examples of the
13 to
rapid
14
evolution of
sharp
predatory
teeth in both its
dinosaurs
upper
around
and lower
225
jaws,
million years ago.
short front paws with
At the
5
same
fingers,
time,
and
the
long
first
hind
plant-eating
legs that
dinosaurs
allowed
appeared
it
in
to
the
run
fossil
fast.
record.
Pisanosaurus was a 1-meter-long dinosaur that weighed between 2 to 9 kilograms. It had closely spaced teeth, forming a continuous edge for grinding plant matter. By the late Triassic period, there were at least 15 different species of dinosaurs. During the Jurassic period, Earth's climate changed from hot and dry to a much more humid and subtropical climate. Forests of ferns, palms, and conifers began to cover the planet, and the air became warm and moist with tropical breezes. At the beginning of this period, the breakup of the supercontinent Pangaea continued and accelerated. Laurasia, the northern half of the continent, broke up into North America and Eurasia, while the southern half, Gondwana, began to break up. During the mid-Jurassic, the eastern parts of Antarctica, Madagascar, India, and Australia split off from the western half, including Africa and South America. New oceans flooded the spaces between these landmasses. Huge mountains rose on the seafloor, and sea levels climbed higher onto the continents. This water created the humid subtropical climate, turning deserts into lush landscapes with palm tree-like plants and conifers such as araucaria and pine. The oceans became full of diverse and abundant life, with marine reptiles like plesiosaurs, with their long necks and paddle-like flippers, at the top of the food chain. Among these were giant marine crocodiles, sharks, rays, ichthyosaurs, squid-like cephalopods, coiled-shelled ammonites, sponges, snails, and mollusks, all thriving in the ancient oceans. Coral reefs grew and expanded rapidly in the warm waters, and microscopic plankton increased so much that they may have turned parts of the ocean red. The earliest known bird, Archaeopteryx, took to the skies in the late Jurassic, likely evolving from an early coelurosaur dinosaur. Archaeopteryx had to compete for airspace with pterosaurs, flying reptiles that had been buzzing through the sky since the late Triassic. Meanwhile, insects like leafhoppers and beetles were abundant, and many of Earth's earliest mammals scurried around at the feet of the dinosaurs. It was during this time that dinosaurs began making their mark in a huge way, literally. Small quadrupedal plant-eating dinosaurs gradually evolved into multi-ton giants. One of the plant-eating giants, Brachiosaurus, reached 16 meters in height, stretched about 26 meters long, and could weigh as much as 25 tons. Another herbivorous giant, Diplodocus, was 27 meters long and weighed between 30 to 50 tons. The sheer size of these dinosaur giants may have deterred attacks from a bulky, meat-eating dinosaur that walked on two powerful legs. Also living during this time, the ominous Allosaurus. This huge carnivore ranged from 7 to 12 meters long, weighed nearly 2 tons, and had 16 sharp teeth in its upper and lower jaws. Like many predatory dinosaurs of the Mesozoic era, Allosaurus constantly grew, shed, and replaced its 3 to 4 inch teeth. This dinosaur was fast, with models suggesting it could run up to 34 kilometers per hour. Fossil evidence shows that Allosaurus preyed on Stegosaurus, and the plant-eating dinosaur fought back by punching holes right through Allosaurus bones with its spiky, clubbed tail. This could explain why Stegosaurus had such a long run and survived all the way up to the late Cretaceous. But new predators would emerge that were just as terrifying as Allosaurus. The North American Tyrannosaurus rex could grow 12.5 meters long and weighed between 8 to 10 tons, though some researchers now suggest it may have weighed half of these estimates. However, T. rex wasn't alone in the meat-eating dinosaur category. It was either outclassed or equal to two other sharp-toothed monsters, the South American Giganotosaurus, which had the same type of build and weighed 9 tons, and the 10-ton Northern African Spinosaurus. Still, T. rex was a vicious predator, if not downright unhygienic. Experts believe that shards of rotten, bacteria-laden meat were constantly lodged in its closely packed teeth, which gave the animal a septic bite that would eventually be fatal to its wounded prey. Of course, this process would have taken several days or weeks, and another T. rex would likely reap the rewards. Scientists examining the T. rex skull determined it had a bite force of between 1,500 to 5,000 pounds per square inch, allowing it to take bites of flesh in the 225 kilograms range. However, like Allosaurus, T. rex also had problems with its prey. It lived in the same region and time period as some armored, plant-eating dinosaurs. One of the most iconic dinosaurs next to T. rex is Triceratops, which means three-horned face. All Triceratops had three-horned skulls, two massive horns above the eye sockets, and one smaller horn over the nose. Weighing around 6.5 to 13 tons, the largest Triceratops was 9 meters long from nose to tail, with the tips of its shoulders standing 3 meters off the ground. Triceratops had teeth arranged in ditto batteries, and each tooth was stacked in a vertical column of 3 to 5 teeth, forming rows with 36 to 40 tooth-loaded columns. This means that a single Triceratops could have 800 teeth at its disposal. It had a narrow beak and powerful jaws that allowed it to grind down tough vegetation and trees. It was one of the last non-avian dinosaurs to evolve by the end of the Cretaceous. Ankylosaurus is another of the most famous armored dinosaurs. It was the largest ankylosaur and the last of its kind, thought to have lived right up until the end of the Cretaceous period. The body of Ankylosaurus was covered in bony plates, and it had a beak and teeth, along with 4 horns that projected backward from its head. Its tail ended in a club, which provided protection from predators. This would have been useful, as Ankylosaurus lived alongside T. rex and other meat-eating predators. At some point during the middle of the Cretaceous period, dinosaurs from the ornithopod family evolved into the popular hadrosaur or duck-billed dinosaurs. They were large, oddly shaped, low-slung herbivores with tough beaks on their snouts, which they used for shredding vegetation. These dinosaurs are believed to have lived in herds and were capable of walking on 2 legs. Sauropods became even bigger by the late Cretaceous period. You may have thought that Brachiosaurus and Diplodocus were big, but by the late Cretaceous, there was another dinosaur that could possibly be the biggest land animal to ever walk the earth, Argentinosaurus. This behemoth could reach 30 to 40 meters in length and weigh between 50 and 100 tons. It was a member of the Titanosauria, the dominant group during the Cretaceous period. and was a herbivore like its earlier sauropod cousins. There was also a strange new breed of dinosaur that lived 20 million years before they all went extinct. They were called pachycephalosaurs, or bone-headed dinosaurs, and they had bizarre-looking skulls with horns on the snout and around the base of the skull. These might have been used to fight off the last of the big predators, or even to show dominance over their own species. Of course, there are more than 700 different dinosaurs that have been discovered so far, but there's not enough time to cover them all in one video. Some dinosaurs lived in colder regions when they were further south, within the Antarctic Circle, during the Cretaceous. During this time, there could have been snow and ice, with temperatures as low as -10 degrees Celsius during the 3-month-long dark winters. A variety of different dinosaurs lived in this polar zone. In 2014, a skull section, along with upper and lower jawbones, was found from a miniature Tyrannosaurus called Nanotyrannus or Nanaxosaurus. It's believed that many dinosaurs had feathers to protect them from the elements, and this tiny T-Rex cousin was about 6 meters long. It's now believed that all species of Tyrannosaurus rex had feathers to protect them from the elements, and Nanotyrannus was no different. Other dinosaurs, like the horned and duck-billed dinosaurs, along with small feathered predators like Oviraptor and a small herbivore named Lilinosaura, also lived in the polar region. But their time would soon come to an end. Everyone talks about how dramatically the dinosaurs went extinct, but judging by the whopping 165 million years they survived, they might just be the most successful vertebrate animals to ever exist on planet Earth. In fact, some dinosaur relatives are still around today. Modern-day birds are descendants of feathered dinosaurs, and you might be surprised to learn that crocodiles are the closest living relatives to birds, as they share a common ancestor. The two groups are the only known survivors of the archosaurs. We all know what happened to the dinosaurs, and if you missed our video on the day the dinosaurs went extinct, we'll put a link in the description for you. Please let us know in the comments what you thought about the video and tell us what you'd like to see next. Stay tuned for more cool videos, and thanks for watching.